We're going to continue with our chapter of aqueous reactions in solution. Last time we learned a little bit about double replacement reactions, and we took it to the AP level in the sense that we now know how to write net ionic balanced equations for these double replacement reactions that generate precipitates. So you're going to have ions generating a solid. We just want to finish up with the stoichiometry of that section and also illustrate how we make particulate diagrams. This is something that the AP exam really goes into now. And in your textbook, with those problems I assign at the end of each chapter, you really want to make sure that you do what's assigned, but especially any problem that has those beakers with the colored ions, and I listed those problems down, and we'll be sure to take a look at them. In regard to your notes, we had done 410. I want to do 411 with you. This just further illustrates this concept, and then I'm going to show you how to draw either a molecular representation or particulate diagram. Those phrases are somewhat synonymous, and we'll illustrate how to do that. On 411, it says you have aqueous solutions of sodium sulfate and lead 2 nitrate. Lead 2 sulfate is going to precipitate. You want to calculate the mass of that precipitate from quantities of reactants provided. So let's take a look here at how to work this problem. I always like to write at least the reactants, or in this case a balanced chemical reaction. They're also asking you to write the net ionic balanced equation for further practice. So what you are looking at in this particular problem is you've got sodium sulfate reacting with lead 2 nitrate, and you're going to generate lead 2 sulfate and sodium nitrate. Balanced equation. Once you have that, you can get the information down. We're looking for the mass of this one. So essentially the theoretical yield of the lead 2 nitrate. Just be careful, the information's given a little bit backward. In regard to concentration, we have 0.0500 molar. We have 1.25 liters of it. In regard to the sodium sulfate, our concentration is 0.0250 molar, and the volume is 2 liters. How might we go about doing this particular problem? How are you going to convert that to moles? Exactly. So if you multiply these two quantities, you're going to get moles. And this is a 1-to-1 mole ratio, making it simple. If you have a 1-to-1 mole ratio, that's your need. Comparing it with your given, clearly whatever you have less of, if you have a 1-to-1 mole ratio, is your limiting reagent. So this is your limiting reagent. If this is your limiting reagent, how many moles of lead 2 sulfate will you generate? Say it again. Lead 2 sulfate. Exactly. So if you have 0.0500 moles of your limiting reagent, and now this is a 1-to-1 mole ratio, you're going to have that many moles of lead-2 sulfate, and then from the periodic table you can determine the mass of the lead-2 sulfate, and that's going to be 15.2 grams of lead-2 sulfate. Pretty straightforward. There's really nothing there that you didn't know previously. The other thing they ask you to do is write the net ionic balance equation, and this I think some of you are struggling with ever so slightly. In this case, you already know your precipitate. How do you know sodium nitrate isn't your precipitate?
Nitrates are water soluble and sodium is group 1.
Right, so you've got a compound that contains a group 1 element. Keep in mind hydrogen's in group 1, but it doesn't fall in this category, so be careful with the hydrogen concept. But all nitrate containing compounds are water soluble as well, so you're not going after this one. In fact, if I asked you for the spectator ions, what would those be?
Sodium.
Sodium ion, Na+, and nitrate ion, NO3, 1-. So you can just work backward. What two ions comprise this compound? You got it. And that's your net ionic equation, and it's already balanced. Nothing difficult there. All right. Going back into the notes, this is the piece that's going to look very foreign. There are many advantages of this concept. I go over it because I know it's on your AP exam. Diagrams are great. It says write a balanced net ionic equation for the following and draw a molecular representation, or sometimes it says particulate diagram. When they first came out with the new improved AP exam, they were saying molecular representation. Now I'm seeing more of a particulate diagram. We're seeing that wording. I'm going to do the first one with you. The second problem is not in your notes. I added it last period because the kids felt like they needed another one. Let's do the first one together, and then I'll let you try the second one. In this one, it says you have an 100 ml aliquot of 0.5 molar aqueous lithium hydroxide. That's one piece of information. It's mixed with 350 mils of 0.1 molar aqueous magnesium nitrate. And I'm telling you to let 1 unit be 5 millimoles. I'll explain what that means, and I'm going to walk you through this one in terms of what it's asking and what the expectations are. In your practice quiz, which I'll give you today, your part 2 question will be very similar to this, as well as many of the other concepts we've discussed in this particular chapter. So what we have in this particular problem is we've got lithium hydroxide reacting with magnesium nitrate. of the lithium hydroxide, my concentration is 0.500 molar, and my volume is 100 mils. The other compound has a concentration of 0.1 molar and a volume of 350 mils. What two compounds are generated? So you've got magnesium hydroxide, correctly formula written, that's my solid, and lithium nitrate. Okay.
Quick question.
Yes.
How do you know that one's a solid?
This one?
Yeah.
Because the other compound contains lithium, a group 1 containing compound is water soluble. In addition, all nitrate containing compounds are water soluble. All right. Same approach here. How many millimoles? 1/2 of 100 is? At this point in your chemistry life, you should be comfortable determining limiting reagent, especially if the coefficients are 1 and something in your head. Your need is from the balanced equation. For every 1 mole of this, you need 2 moles of this. So you need twice as much of this as you have of this. Do you have twice as much of this as you do of this? No. And therefore, this substance is your limiting reagent. And you can explain it as such. You can indicate that 50 millimoles is not 2 times as much as 35 millimoles, and therefore lithium hydroxide is the limiting reagent. If you want to start dividing by 2 and going through the whole kit and caboodle, that's fine. But some of you definitely need some time-saving tricks, and that will serve you well. And if you can do it that way, you also truly understand the concept better. So you know what your limiting reagent is. For every 50 millimoles of this, how many millimoles of magnesium hydroxide will you generate?
25.
You are correct because of the 2 to 1 mole ratio. Okay. Our next approach is to write the net ionic balanced equation. So what we have here, and this was Sarah's question earlier, I understand it, I'm not sure if you guys did, but she said you have to go hydroxide ion plus magnesium ion, because typically when you write these, you do go cation, anion. So it doesn't matter, do whatever you want. But don't confuse yourself because you've got all the information here on the left. So I'm actually going to do it backward. I'm going to do hydroxide ion plus magnesium ion yields magnesium hydroxide. Now, in this question, it's going to work out easily, but I want to point it out in case it's not easy in another one.
I was having a question about, like, You said we could eliminate a bunch of the work. So like on a test, you won't take points off for us not having work.
For part one, I don't care, because that's multiple choice.
Oh, yeah.
And this would be a multiple choice type question at this point. When you do the drawing, that's what makes it part two. If they ask you for the limiting reagent, you need to provide some explanation.
Okay.
And it can be as simple as what we just said. This
so it
quantity
can be a
is,
sentence and not like the equation.
Yeah.
Okay.
I mean, you'd have to show how you got that, but I mean, you know.
Yeah.
Here you go. That's how I got it. All right. In terms of, I'm going to do this down below. In terms of the lithium hydroxide, we generate one lithium ion and one hydroxide ion. So if this is 50 millimoles, then so is this, correct?
Yes.
All right. Similarly, for the magnesium nitrate, you get one magnesium ion and two nitrate ions. So if this is 35 millimoles, then the magnesium is the same. And that's something you do want to check. You don't necessarily have to check it this way, all worked out, but it's something you want to look at. I look at this, I know there's one hydroxide ion, there's one magnesium ion. So I can now move these quantities down. But if it's not, you may have to do some mental stoichiometry. Are we good at this point?
I'm confused what you did on the bottom.
All I was proving was that to go from lithium hydroxide to hydroxide ion, for every one lithium hydroxide, there is one hydroxide ion.
Yeah, so wouldn't it be 100 millimoles?
No, 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 no.
Because you have a 2 now.
No, 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 no. That's showing you what you need, not what you're given. Careful. For every 1 mole of magnesium nitrate, 1 mole of magnesium. Now, if you were going after the nitrate ion, how many millimoles of nitrate ion are there?
70.
Right. And that's the only point I'm making. In this case, they were 1 to 1, so it didn't matter. But this would be 70 millimoles. This one would still be 50, but I'm not going after those. But it's just something you do have to look at.
So the coefficient of the net ionic equation doesn't matter.
It will in a minute, but not for what you're given.
So if it is 70, you just change the 35 to 70?
If you were going after that one. Katie, you have a question?
What's that, like, okay, so you, like, the 25 millimole, like, where, how'd you, like, up, like, at the top, like, what is that?
Oh, here, if you were going after how many millimoles of product were generated, because of the 2 to 1 mole ratio, you would half this to get that. They didn't actually ask for this at this point, but I'm going to show you where you need it. So we established that this is the limiting reagent. You can see it clearly here. And again, and this is Katie's question, so for 50 millimoles of this, from the 2 to 1 mole ratio, you can see that you generate 25 millimoles of this, correct? Okay. The piece of the puzzle that's new is the particulate diagram, and I'm going to do that right here. On your quiz, I made it easy. Your practice quiz is a little bit harder, but that's good because by the time you take the quiz, you'll be like, woohoo, she gave me a break. Which I'll always try and do. I'm listening.
Why for that top one with the magnesium hydroxide? Is it, well, wait, never mind.
You answered your own question?
Yeah.
Super.
Dr. Kirsch, why do you make it bigger on one side?
I know.
What?
Your little flasks is driving me crazy.
You make them like wide on one side. and-
Yeah, because they have a little spout you can pour out of.
Oh.
Do we have, we're gonna have to color for the?
I drew it for you on your quiz. I made you a little beaker, but it didn't have the spout because I just could make ovals and stuff.
Wait, so on the test we have to draw it?
No.
The test.
This, I drew this little beaker for you on the test.
No, but as in the AP
like the
exam.
unit.
I think they would give you the beaker.
Okay.
What about the?
Why is it 50 millimoles plus 50 millimoles of hydroxide? But then on the other one, it's 70 millimoles plus 35 millimoles, which is 35 millimoles.
I don't understand your question.
There's 2 nitrate ions in the
Oh.
second.
No, I get why. Okay, wait. I think I get it.
And you don't actually need that. I was just illustrating a point.
So if it's 50, then it should be. It's like 1 to 1 mole, right? Like they would each get 50, and then depending on how many moles you would then multiply. Okay.
All right. I also on the quiz gave you a nice key. So for example, hydroxide ion can be that, and magnesium ion can be this. And if we were looking, well, I didn't give you the key for the product, so we'll figure that out. All right, so in the problem it says let 1 unit equal 5 millimoles. If I have 50 millimoles of hydroxide ion, then you need 10 blue circles, right? I'm going to be sorry I colored those in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't have to color yours in. How many rectangles for magnesium if each unit is 5? Super. Now these are ions, they are aqueous, they are moving all over in the water. Hang on.
Can we make it a blue rectangle?
You can do whatever you want. It's a free country. Okay. Now, when you have magnesium hydroxide, you're going to have 1 magnesium and 2 hydroxides, right? All right? Now, those are precipitates. They're solid. So are they going to float or sink?
Sink.
They're going to sink. Now, here's the key. Did I?
Because we did the diag equation.
Problem was
Sorry, I wasn't.
That's okay. Other kids were wondering the same thing. Alrighty. Now, what's your limiting reagent?
Oh, I know this. It's
The hydroxide ions. So these have to be used up. And you have 10 of these. So how many of these are you going to make?
5.
Alrighty.
Why?
We're cooking with gas.
But we already know that from the 20.
I know.
Oh, so we do it either way? Do they have to be all of them?
They should be toward the bottom because they sink.
Those are beautiful.
I know, they're so cute. Alright, we used up all of these. We used 5 of these. How many are left?
2. There's floating.
They just flow.
This is a particulate diagram.
This
It is so cute.
This is brutal.
It looks like candy wrappers.
Okay, that's simple.
I'm hungry now.
That makes sense.
Is this
Maybe
all the
that's
points
why.
on the quiz after here?
It's your part 2.
Oh, yes.
Alright?
But you have to determine it all first.
Now, on your practice quiz, I made you diagram like crazy because I figured you would get good at it.
I think you enjoy that.
By the time you get to your quiz, I'm really only going after the last piece because I got to grade it and you're going to drive me crazy. So,
Could you even take the listen to it?
Picture of a beaker.
I made a picture of the beaker on your quiz and you just have to put the little guys in there. Now the beauty of these particulate diagrams, according to the College Board, is that you truly can see which substance is limiting and which substance is in excess. Now sometimes with these diagrams, you do have the spectator ions chilling in there as well. But I didn't do that on your quiz. Andrew, you had a question. I answered it? Okay.
Will they include the spectator ions on the exam?
They could. And in your textbook,
They do.
what you will find in your textbook is that there are a few problems addressing this concept in my little cloud here on pages 172 to 174, questions 24, 49, and 62 have little beakers. And those problems are much easier than this one. All right? Now I'm going to give you one to try. Faith, question.
On the AP test, are we gonna have to put the spectator ions?
I haven't seen one yet where they actually make you draw it. You're more going to be looking at, you're going to be interpreting it.
Okay.
But if you can draw it, you're so golden.
So,
So-
we'll be on the free response, right?
I did on your part 2 question on your quiz. Part of the part 2 question for your quiz, which is next week or the following week, I think it's the following week, I had you draw one, but I linked it to another concept.
But not on the AP exam, we won't have to follow.
You never know.
Part 2 is gonna be like electrochem.
No, you'll see. All right. This was the problem we just did. This problem is not in your notes because I added it this morning, but I would like you to take a few minutes to try it now. Go!
Keep going.
I have extended time.
Just like on the Food Network, your time starts now.
Laughing.
I love chopped.
All right, let's go. You can do it, you can do it. And you're doing the same type of thing. I want that particulate diagram.
You gotta figure out it's getting like a
They're in the bottom tray. Don't take them through that and you're going to kill them.
Yeah.
Sure is.
Do it again.
Do it again.
Do it again.
CH3COO minus.
Yeah, you're right.
Oh, geez, this is the one where
Iridium is in the bottom left.
acetate.
Oh, God.
Hey, the videotape is rolling. Let's watch our language, please.
That was fake.
It was not me.
Chase, it was definitely
Dr.
you.
Kayla, she said the F word in front of my mom.
We're getting
I
this
did
all
it again. No way. Yeah.
A-L.
Oh, yeah, she was her fake person.
CH3.
Yes, but this is in excess, so this is not the true amount of this, so the limit, and this should have a 1 minus charge on it.
I've never heard of rubidium.
Minus, S minus.
Oh, I'm an idiot. I was thinking right. No.
Oh, so late. What are you on?
What do you want?
That's acetic acid.
What does that mean?
If you put the H, that's acetic acid.
What's the charge charge on acetate?
1 line.
He knows everything.
You don't know
He
what
was in
to
it
say.
last year.
Huh? CH3COO 1 line.
Thank you. I was doing it together. Yes.
Wait a minute. I forgot to balance my equation.
That's because why does acetate not have like the group?
Say what?
Why does acetate not have the group?
Because the H, if you put the H on the end, you'd have acetic acid. So the ion is essentially the conjugate base of the acid.
That's not fun.
Yes. Yeah.
No, and then this one has
You already put a 3 there, so you already
no, okay.
It should be 3, 2, 6, and nothing.
Yeah.
Key.
Which doesn't seem right.
You're doing like the whole thing, the diagrams and meta equation.
Yeah, we're just doing a problem that we just did, just on a different way. Same thing, actually, yes.
Which is, what's the mathematical?
Huh?
What are the coefficients?
Dave, you know how to balance a chemical equation.
Yes, I know, I just am having.
3, 2, 6.
Okay, that's what I thought, the 6 kind of threw me off. I've already known.
What's that? No, because you're multiplying 1 times 200.
So fine, right?
Huh? Oh, okay. And they're talking about aluminum sulfide.
Three M's.
You have to find, you have to find, on the other one, it told you which one was the Yes, so, yes. I know. I'm, my little pupil has grown up.
You're his pupil. Aluminum sulfide?
You have to break it down.
No, aluminum is 3+.
It's too much work to do, I can't.
What's the milling? What's the milling?
Yeah, you did.
How we doing?
Wait, hold on. Hold on a second. I didn't even start.
Okay, so she did it by doing
Sarah,
solid.
is the aluminum one,
How do you convert millimoles?
is the aluminum one precipitate?
It's the same ratio. Moles to moles.
multiply it by 3 for sulfide and multiply. Wait a minute. No, because it's how much you're taking. So, how much sulfide is in here?
Particulate is the
Oopsie. I forgot to take attendance.
Let me do it first. Wait, don't put it up. Shit.
I'm not putting, oh, I put it up.
No.
Don't put it
I
up
have to
yet.
take attendance.
I don't want to look at the answers.
Don't look.
You could have frozen it.
Chase,
Oh, go.
I really wanted to watch you like down.
I didn't think of that.
Yeah, I really just wanted to do it.
All right, let's take a look. You could do all this without a calculator.
I'm giving my 200 by 3 without a calculator.
What's 20 over 3?
60.
All right, let's take a look.
Okay, she's going way too fast for me.
How'd we do?
Horrible.
Don't look if you're not done.
Dr. Caleb, you gotta slow down here.
What's 200 divided by 3?
What's 20 divided by 3? 6 and 2/3.
Wait, which one are you on about?
Oh my god, Chase, stop saying that.
You actually don't need this quantity here.
I told you.
Which quantity don't you need?
Stop yelling at me.
That way.
Teacher was throwing me off. I
Go
didn't
back to
understand.
what?
That's why I'm not gonna come and teach you.
I'm going to go over it.
That's why I didn't understand. I was like,
All right.
what is the 66?
Dr.
Yeah,
Caleb.
but hey, you guys, but you're way. I mean, you've like screamed out 17 things already. I heard the how do you not know acetate yet? You should know acetate. It was in the summer
I did not
assignment.
say that. No, I did not say that.
What's 20 divided by 3? Yeah.
I know acetate. I don't.
And then you're teasing him because he knows acetate. You should know acetate, silly.
1 mole of
That's because it's all a video.
Yep. Alrighty.
Let me draw a flash. Okay, cool.
Alright, just look for a sec.
I don't like drawing these flashes.
You have acetate in that flash. Shouldn't.
First thing you want to make sure you can do is write that net ionic balanced equation. You knew that you were getting rid of the rubidium ion because rubidium is in group 1. Some of you may know that all acetate containing compounds with the exception of silver acetate are water soluble. So acetate was not part of your precipitate. I think you should have been able to easily calculate the millimoles of both reactants. And you should be comfortable writing that precipitation reaction in net ionic equation format at this stage of the game. In regard to the limiting reagent, that piece was really easy this time because you needed 1.5 times more sulfide ion than you do aluminum ion, and you have less of it. So right away you knew that sulfide ion was your limiting reagent. Is the concept that you needed 1.5 times more of this than you have of this clear?
Yeah.
Where did I get the 1.5 from? Okay. So once you established what was the limiting reagent, by dividing by 3, you could figure out how much of this you get, although you didn't really need that.
Cool. How do you get that?
200 divided by 3.
Dr. Caleb, I'm so confused about the thing you did at the bottom of the last problem and how that would affect the coefficients that match.
Okay.
Can
So,
you do that again?
yes. In regard to Faith's question here, one question at a time, please. In regard to rubidium sulfide, you know that rubidium sulfide is comprised of rubidium ion and sulfide ion. You'd have 2 of these and 1 of these. You have you don't need, it doesn't even matter. You have rubidium sulfide here, and for every 1 rubidium sulfide, you generate 1 sulfide ion. So whatever the millimole amount is here will be the amount here, regardless of this coefficient. Similarly here, for every 1 mole of this, you have 1 mole of aluminum ion and 3 moles of acetate ion. So again, a 1-to-1 mole ratio, so whatever this is this. Once you establish that, then you're ready to draw your particulate diagram. And again, the beakers should all be the same size. I drew this one large because I wanted you to be able to see from where you're sitting. On your quiz, I made up a little key for you because one year I didn't, and trying to grade it was a nightmare. So I've learned that a key makes it easier for you and easier for me. From this key, how do I figure out I have 8 circles?
200 divided by 8.
200 divided by 25 is 8.
Yeah.
10 stars here because 250 divided by 25 is 10. Now, I gave you this key. I won't give you this piece. You have to establish this. You don't want to put 2 ions of the same charge next to one another, so I just made it simple and I made a little chain. You've got 2 stars for the aluminum ions, 3 circles for the sulfide. That's your precipitate. It will sink. Your limiting reagent is sulfide ion. For every 1 aluminum sulfide, it takes 1, 2, 3. 1, 2, 3 used. 1, 2, 3 used. You can see them here. You have 2 left over. And for every 3 sulfide ions, you need 2 aluminum ions.
How'd you know these 2 aluminum sulfide?
And that's the answer. You're going to use 2, you're going to use 2, and you have 6 stars or 6 aluminum ion remaining.
What is that supposed to mean?
Dr. Caleb,
Yes.
why did you divide 200 by 25?
Because I said let one unit be 25 millimoles, and that would tell me how many symbols I needed in each beaker.
Was that like something you made up, or was that something you found out?
Given right here. And it will be given also on your quiz to make it easier. Okay? What you definitely want to do for next time, on your practice quiz, which you'll get today, part 2 has a problem like this with some stoichiometry built into it. That will help you prepare for your quiz. If you do that for next time and you feel like you've got it, superb. If not, we'll do another one like this next time. Sam? Not for a while.
Oh, thank God.
Okay?
So can I,
One thing at a time. Here's your particulate diagram. And at this point, hopefully, you feel comfortable in regard to reaction types. We have now talked about double replacement in regard to precipitation type reactions at length. You want to be able to write net ionic equations. You want to be able to easily do the stoichiometry involved with them, and hopefully, after an additional one, the particulate diagrams. It's not difficult, it just requires practice. I wish we could do 10 this period, but we cannot. All right? Do this for next time. See if you're comfortable with it. If not, I'll make you up another one for next time. Okay?
we're gonna have to do like the ionic reaction?
Net ionic balance
No, no, no,
equation.
Like the regular ionic.
You mean the molecular equation. You don't need it in this case.
Okay. Mind if I stand?
You're fine. Okay. I think we're going to take a brief break. There's something I need you to do with the break. After the break, we're going to do some acid-base type reactions. Some of it will be review, which you will welcome. Some of it will be new. Nothing there is terribly difficult, and I'm going to simplify it greatly so it's not overwhelming.